The life of a star starts as a cloud of hydrogen gas, which is called a nebula. The force of gravity between all of the atoms in that nebula will result in the cloud slowly contracting towards its center. This will result in a dense ball of hydrogen, which is now referred to as a protostar. As it contracts, the gravitational potential energy of the gas is converted into heat energy, which warms the protostar. If the protostar has enough mass, the temperature and density will cause fusion in hydrogen atoms, which turn to helium after fusing. The process of fusion generates more heat, which further warms the core and the outer layer made of hydrogen. Once fusion starts, the protostar becomes a main sequence star. Over time, because of fusion, more helium will be produced, and the star and its core will be produced of more helium rather than hydrogen as this happens. The outer layer will stay as hydrogen throughout the process, however. As further time passes, the hydrogen will begin to run out. When the star exhausts the hydrogen in its core, it will expand to become a red giant or a red supergiant, and fusion will begin to generate heavier elements than helium, such as carbon via the triple alpha process. If the star is small, it will run out of heat and shrink in size as it cools down. The star will first shrink to become a white dwarf, then further cool down to become a black dwarf. If the star is large, which is more than 1.5 times the size of our Sun, then the fusion process can continue to make heavier atoms capture iron on our periodic table. Once it begins generating iron, the star will no longer be able to produce enough heat in the core to remain stable. The star will explode in a supernova, leaving behind a dense neutron star. However, if the star is very large, which is 3 times the mass of our Sun, then the supernova will leave behind a black hole, whose plasma will feed on the matter from its glowing hot accretion disk. When a supernova occurs, the outer hydrogen part of the star and part of the core will spread out into space and cool. This creates a cloud of hydrogen gas, which, if big enough, can start the whole process over again.